Hello there. We have here a stationary wave question. Two progressive waves travel in opposite directions and form a stationary wave. The graph shows the variation with distance x of the displacement of the stationary wave and of one of the two progressive waves at the same instant in time. So if we recall, the definition of stationary waves is basically when two similar waves that are traveling in opposite direction and meet at a point via superposition, it will form a stationary wave. Now the question is asking what are the approximate displacements of the other progressive wave at the positions J, K, and L. So a brief recap on what is superposition between two or more waves is basically what we call the algebraic sum. Okay, the algebraic sum of the displacement. So that means the y-axis of each of the individual progressive waves. So we sum them up together in order to produce a superposed wave. So stationary wave is a specific type of wave that is formed when the conditions are met, for example, traveling in the opposite direction and whatnot. So what we have here is basically two waves. Let me just highlight. We have here the resultant stationary wave. That means it is the resultant of the superposition between two progressive waves. Let's just label this as the stationary wave. And then we have another one, which is the progressive wave P1. So basically, the stationary wave is formed when P1 meets at P2. P1 meets with P2 at a particular point. So here in this question, we are required to find out what is P2 or the approximate values of P2 at points J, K, and L. So let's say, for example, we can just use this as the term that the formula that we use. P2 is equivalent to S minus P1. So any displacement of the stationary wave, we just subtract with the displacement of P1. For example, at point J, okay, we want to find out what is P2. P2 is equivalent to the displacement of the stationary wave at S, which is minus 5. Okay, and what is the displacement of P1 at point J? It will be 0. So sorry, it's not supposed to be plus, but it's supposed to be minus. So here you'll get the value at J is minus 5. So automatically C and D are eliminated. Now at point K, P2 will be equivalent to what is the displacement of S at point K. So here we see is approximately positive 5. And what is the displacement of P1 at point K is also almost the same. So it is basically minus positive 5. So here you'll be 0. So from here we know that J is minus 5, K is 0. So the answer would be A, because this is not correct. So let's just check the final point, which is at point L. P2 will be equivalent to S minus P1. So what is S at point L? S at point L is 0. And what is P1 at point L is approximately 10. So this one is minus 10, positive 10. So P2 will be minus 10, and this is consistent. So that's how you get the other. So the issue here is you need to identify the other progressive wave. That means we want to find out what is P2 if we define the first progressive wave as P1 and S as the resultant stationary wave.